So let's see if we can do the p-value method that we just did in a fraction of the time. And while we're at it, step 3 and step 4, we ignore classical method with StatCrunch because who needs it? Okay, so go to stat. We're testing proportions here. We've got a 2 sample. We don't have data really. We have a summary. Data would be like lists of yes, no, yes, no's and stuff like that from the data set, which we don't have. We do know that we had, now let's think here. I don't know if I'd call aggressive behavior a success, but apparently it is. All right, so let's look. So sample 1, we can let that be the a lot. It doesn't really matter, but we had 154 successes out of 619. Again, the more aggressive acts is a success in this case, but that's success in the statistical standpoint, not necessarily the real life standpoint, right? Okay, so then next, we want to do a hypothesis test. We say that it's 0. We did a two-tailed test. I wonder how we're going to get confidence intervals. Worry about that later. Next, and calculate. And there it is. And hey, look, 4.0359, just like we said. And then the p-value is less than 0.0001, which makes sense because we found it to be 0.00005. That's the one downside to StatCrunch, is that it sometimes doesn't tell you the p-value, especially if they're low numbers. It'll just tell you that it's really small, which is basically what this is telling you. And you can double check all your numbers here to make sure it makes sense. 154, 619, 5, and 88, and jazz. And I copied that, I think, and I'm going to paste it in here. Ta-da! There you go. Just to have for my own future reference. All right, cool. So now we know that that p-value is really small, and StatCrunch confirmed it. And I like doing that because StatCrunch I personally like a lot better than Excel for something like this anyway. So let me go back to my spreadsheet. Now, my p-value is really small. So p was 0.00005, which is less than alpha. Alpha was only 0.05, so we reject the null hypothesis. Okay? Then step 6, we would say there is enough evidence to support the claim that there is a significant difference in aggressive behavior, aggression levels, whatever. Aggressive behavior between those teens who watched less than an hour a day of TV and those who watched more than an hour a day. Cool. Now, one thing to keep in mind as we talk about this, and this is more chapter 1 stuff, but keep in mind that there were a couple issues with this data set, and I really didn't get into them because I was trying to teach you the methods here. For starters, this was only, how many people? 88? 88 are in the less than an hour a day. And I don't know. To me, maybe it should have been 2 hours a day, because an hour a day is barely even like one TV show. So these are people that are watching less than a TV show a day. It seems to be a little bit outdated. Also, you're talking about 17 years. There's could be lots of factors going on here. Another problem that we ran into, and I didn't really talk about it, was that you're supposed to have right here, n1 times p1 times 1 minus p1 is supposed to be greater than 10. That's actually not the case in this particular example. I can show it to you right here. If I take n1, which is 88, times, actually that was n2 for us, but that's okay, times p1, which is this one, the little, times parentheses 1 minus p1, there, it's 4.7, not over 10 like it was supposed to be. So that actually creates problems for us, and I just didn't get into it because I didn't want to at the time. So those were all the issues that you'd have to address if you were going to write this up. Okay, next time I come back, we will construct this confidence interval right here. I'll see you then.